Have you ever looked up at the sun and wondered, what if it just exploded? Or what if one of those massive solar flares we hear about hit us head? Could our friendly neighborhood star actually be a ticking time bomb waiting to destroy Earth? Today, we re-diving deep into the heart of the sun to uncover the truth about solar flares and answer the big question. Are we doomed? First, let's get one thing straight. The sun is not going to explode in the way a supernova does. Our sun just isn't massive enough for that kind of dramatic exit. Instead, in about 5 billion years, it will swell into a red giant, likely engulfing Mercury, Venus, and possibly even Earth. But that's a problem for the very, very distant future. What we asterisks need to think about are solar flares and coronal mass ejections, or CMEs. So, what exactly are these things? Imagine the sun's surface as a boiling pot of superhot electrically charged gas called plasma. The sun has a powerful magnetic field, and sometimes the magnetic field lines get tangled, twisted, and snap like a rubber band. When they reconnect, they release a tremendous amount of energy in a flash of radiation. That's a solar flare. It's the biggest explosive event in our solar system, releasing the energy of millions of hydrogen bombs all at once. Now, a solar flare itself is mostly intense light and radiation. If a big one were aimed at Earth, the most immediate danger would be to astronauts in space, outside the protection of our atmosphere. But often, these flares are accompanied by something even more impactful: a coronal mass ejection, or CME. Think of a CME as a giant, billion-ton cannonball of plasma and magnetic field being shot out from the sun at millions of miles per hour. If a solar flare is the muzzle flash, the CME is the cannonball. And if that cannonball is aimed at Earth, that's when things get interesting. So, has this ever happened before? Oh yes. The most famous event is the Carrington event of 1859. A massive CME slammed into Earth's magnetic field, and the results were spectacular and scary. Telegraph systems across Europe and North America failed. Operators received electric shocks, and telegraph pylons threw sparks. The northern lights, the aurora borealis, were seen as far south as Cuba and Hawaii. People in the Rocky Mountains woke up in the middle of the night, thinking it was dawn because the sky was so bright. Now, imagine an event of that magnitude happening today. In 1859, the world ran on steam and muscle. Today, our entire civilization is built on a delicate web of electronics. A Carrington-level event could be, in a word, catastrophic. Here's what could happen. When that massive cloud of charged particles hits our magnetosphere, Earth's protective magnetic shield, it would induce huge electrical currents in our power grids. Transformers could overheat and explode, leading to continent-wide blackouts that might last not for days or weeks, but for months or even years. Think about what that means. No electricity, no internet, no phones, no GPS. ATMs wouldn't work. Gas pumps would be useless. Water and sewage systems, which rely on electric pumps, would fail. Our entire global supply chain would grind to a halt. It would essentially throw us back to a pre-industrial age, but without the skills and infrastructure to cope. It wouldn't be the end of the world in a Hollywood asteroid impact kind of way, but it would be the end of the world, asterisk as we know it, asterisk. The potential cost. Studies have estimated that a severe space weather event could cause trillions of dollars in damage and take up to a decade to fully recover from. It's considered one of the most significant natural threats to our modern way of life. So, back to our original question. Could the sun destroy Earth? The answer is no. It won't physically destroy the planet itself. But could it destroy our modern, technologically dependent civilization? Absolutely. It's a low probability, but extremely high impact event. Now, don't panic and start building a bunker just yet. The good news is, we're not just sitting ducks. Scientists and space agencies like NASA and NOAA are watching the sun 24/7 with a fleet of satellites like the Solar Dynamics Observatory and the Parker Solar Probe. They can see these events as they happen, and that gives us a heads up. When a CME erupts from the sun, it can take anywhere from 15 hours to a few days to reach Earth, depending on its speed. This gives us a crucial window of time to prepare. Power grid operators can take steps to protect their systems. Satellites can be put into a safe mode, and we can prepare for potential disruptions. This early warning system is our best defense. Researchers are also working on building more resilient infrastructure. This includes developing hardened transformers that can withstand the electrical surges and creating smarter grids that can better manage and redirect power flows during a solar storm. It's a race against time, improving our technology before the next big one hits. So, while the sun does have the power to cause immense chaos, it's not an apocalyptic monster bent on our destruction. It's a natural, dynamic star, and we live in its extended atmosphere. Solar flares and CMEs are just part of its weather. By understanding the sun, monitoring its activity, and preparing on Earth, we can mitigate the risks. The sun gives us life, light, and warmth. It's the reason we're all here, but like any powerful force of nature, it demands our respect and our vigilance. So, the next time you feel its warmth on your skin, remember the incredible power contained within that star, and appreciate the delicate balance that allows our world to thrive. Thanks so much for watching and exploring this cosmic question with me. What do you think is the biggest threat to our civilization? Let me know in the comments below. And if you enjoyed this journey into space, don't forget to hit that like button and subscribe for more deep dives into the wonders and dangers of our universe. Stay curious.